All right, good afternoon, everyone. My name is Natalia White. I will be your facilitator for the next 4 weeks. The aim of these sessions is for us to have, master formula writing and master equation writing. It's my hope that at the end of this session, you will be able to do very, very well and you will master this topic. I'll give you some form of assessment online too for you to master the concept as well as practice. Homeworks will be sent. I may not necessarily check them one, but we'll definitely review them on a weekly basis. If you're not in the WhatsApp chat, I will drop those shortly. All right, so today my name is Natalia White Gardner. I'm an educator, very passionate about chemistry. I teach at Westwood. I've been teaching chemistry for over 13 years, or probably more. Yes, I love it. I have students who do very well. On a yearly basis, I have students who are on the merit list continuously. I have students placed there. I just make chemistry fun and very easy. So thanks for joining us. Today, we're going to go back to the periodic table so that we can begin to understand what we are doing. Hopefully, we will see it and we won't have any issues. Let me just put my phone on vibrate so we are seeing my screen. Are we seeing my screen? All right, so I will share this document with you shortly. Now, here we have a list of the first 20 elements. So here we have a list of the first 20 elements. We have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, we have potassium, and we have calcium. Now, it is very important that we understand that the periodic table, please mute, there's somebody who's on mute. Can you mute, please? So the periodic table is arranged in order of increasing atomic number. So the periodic table is arranged in order of increasing atomic number. So we move from element 1, 2, 3, 4, 5, 6, 7, 8. The atomic number indicates to us the number of electron. So we're going to track the number of electron now. So here, hydrogen would be element number 1. So it has an electronic configuration of 1. Now, helium is element number 2. It has an electronic configuration of 2. So what we're putting in is the electronic configuration. Now, when we're filling in electrons, the first shell holds a maximum of 2, and the second shell holds a maximum of 8 electrons, and so too is the third shell. So we get to lithium. Lithium is element number 3. So we would put 2 electrons on the first shell, and we are going to go ahead and put 1 on the second shell. Is this clear? We're clear?
Miss, can you go again, please?
We're putting in the electrons. Remember, we said that is the order of increasing atomic number. The periodic table is arranged in order of increasing atomic number, right? So lithium is element number 3, so it has 3 electrons. So apparently you don't want to do that. So let's backtrack a little bit. All right, so let's backtrack a little bit. This is the atomic notation. We have 3 subatomic particles. We have the atomic notation, which is X, A, B, C, D. In X is the symbol of the element, A is the mass number, B is the atomic number, C is the charge, D is the number of entity. Number of entity D is at the right-hand side, bottom right. C is the charge, which is placed at the top right-hand corner. A is the mass number, and B is the atomic number. Now, what we're saying is that the atomic number, the periodic table is arranged in order of increasing atomic number. The atomic number tells us the number of proton. So the number of proton is equal to the atomic number. The number of electron is equal to the number of proton. So a while ago, when we looked on lithium, lithium has 3 electrons because it has 3 protons, right? So it has 3 protons. So it we put the electrons on shell, and the first shell is filled. We must fill the first shell before we get to the second shell. So lithium is going to have 2 electrons on the first shell, 1 electron on the second shell. Beryllium has 2 electrons on the first shell, 2 on its second shell. Boron now is element number 5. Boron is element number 5, and it has an electronic configuration of 2, 3. Carbon has 6 electrons because it's element number 6. Its electronic configuration is 2, 4. Nitrogen has an electronic configuration of 2, 5. Oxygen, what would be the electronic configuration of oxygen?
2, 6.
2, 6. What would be it for fluorine?
2, 7.
And neon would be 2, 8. Now the second shell is filled. So we will move on now to the third shell. The third shell is going to have a maximum of 8 electrons as well. So when we get to sodium, sodium is element number 11. But when we are putting on the electron, it's 2, 8, 1. What would be the electronic configuration of magnesium?
2, 8. 2, 8.
Okay. Aluminum?
2, 8.
Silicon, 2, 8, 4. Phosphorus would be
2, 8, 5.
sulfur would be
2, 8, 6.
chlorine would be
2, 8, 7.
and argon would be
2, 8, 8.
all right. So now that shell is filled, right? And then now we have two, 8, 8, 1, and we have calcium, which is 2. Two, 8, 2. So this is the electronic configuration. Whenever we talk about formula or bonding, we must understand the electronic configuration. And so I'm not taking it for granted. I'm going over about the basics to ensure that we're all on the same page. Now, one point we have made so far is that the periodic table is arranged in order of increasing atomic number. The rows, so in the periodic table, we will have rows and we have periods, right? The rows run from left to right of the periodic table. So hydrogen and helium belongs to the same row. Are we able to identify a row?
Yes, miss.
Lithium, beryllium, boron, carbon, nitrogen, oxygen belong to the same row. Row runs from left to right. And we're saying that the rows are called.
Mommy, tell me something about all I catch up them one day for one day for.
Somebody needs to mute. So the
One day
rows
for
are
and one day
called.
for.
The rows are called
Me not think I just come in.
period. Somebody needs to use. I cannot.
Think to catch up. Me not do nothing to you. Me actually I want class, so me not do nothing to you.
Miss, you're disturbing my class.
A true distraction, man.
Where was I? Notes. Okay, so the rows are called period. The period number is determined by the number of shell. So this means that those in period number 1 would be hydrogen and helium. That is because they have one shell. So hydrogen and helium is in period 1 because they have one shell, and it is the number of shell that determines the period number. Are we clear on that?
Yes, miss. Yes,
So
miss.
we look on the electronic configuration for magnesium, and we're seeing that magnesium on its first shell, it has 2 electrons. On its second shell, it has 8 electrons. And on the third shell, magnesium has 2 electrons. So magnesium has how many shells?
3.
So magnesium has 3 shells. So it belongs to which period?
Period 3.
It belongs to period 3. So the number of shell determines the period number. Since magnesium has 3 shells, it belongs to period 3. Is this clear?
Yes, miss.
Yes, miss.
So magnesium has an electronic configuration of 2, 8, 2. So it has 3 shells, and it is placed in period 3. Are we clear on this?
Yes, miss. Yes, miss.
All right, let's do another one. Let's look on phosphorus. What's the electronic configuration for phosphorus? Phosphorus is P. So it's 2, 8, 5. So that's the electronic configuration of phosphorus. So it has, let me use the CM3. I'm gonna change this one. Let's use no. Let's use lithium. So lithium electronic configuration is 2, 1. A 2 for labeling here. Hello. 2, 1. So how many shell it has?
2.
All right. Any questions so far? Do we understand period?
Understand, miss.
Yes, miss.
All right, so let's go. We have lithium. We have so the first point was that the periodic table is arranged in order of increasing atomic number. We've spoken about that, and we said that it's arranged in rows, and the rows are called period. The periodic table is also arranged in groups, right? The columns are called groups. So the columns in the table is called groups. Column run from top to bottom. So here we are seeing that we have 8 columns. So we're seeing here where we have period number. Period number runs from 1, 2, 3, 4. We're putting in group numbers. We use Roman numeral. So we have group 1, group 2, group 3. These are the columns. The columns are called group. Group 4, group 5, group 6. We have group 7, and we also have group number 8. Clear?
Yes,
Miss.
So as we look there, we are seeing that in group 1, hydrogen has 1 electron on its last shell, lithium has 1 electron on its last shell, sodium has 1 electron on its last shell, potassium has 1 electron on its last shell. We'll go to group 3. Boron has 3 electrons on its last shell, aluminum has 3 electrons on its last shell. We have group 7, those have 7 electrons on the last shell. Chlorine have 7 electrons on the last shell. What do we determine? What can we say? The number of electrons on the last shell tells what?
The group number.
Group number.
Group number is determined by the number of electrons on the last shell. Clear?
Yes, miss.
So the columns are called group, and the group number is determined by the number of the last shell. If we are going to do well in chemistry, what we need to do is to memorize the elements that belong in each group. That is the first thing you need to recall. You need to study the elements that belong to each group of the periodic table. So we are going to take some notes. Elements in group 1, those are called alkaline metals. The elements with 1 electrons on their outer shell are called alkaline metals. Elements in group 2 are called alkaline earth metals. And elements in group 1 are, remember I say you need to study them, those are hydrogen, lithium, sodium, potassium. You must memorize those. Elements in group 2 are called alkaline earth metals, and we have, or I'm not going to put beryllium in there, although beryllium belongs to group 2. So beryllium is in group 2, but I'm not gonna put beryllium there. I'm gonna start with magnesium and calcium. Those are in group 2. And they are called alkaline earth metals. Elements in group 7 are called halogens, and you must know all the elements in group 7 name. All the elements in group 7 are fluorine, chlorine, bromine, iodine. Sorry. And elements in group 8 are called rare, noble, or inert gases, and those have filled outer shell. The elements in group 8, as they have filled outer shell. Now helium, if you go back up here, we're seeing where helium is placed in group 8. Helium is the elements in group 8 have filled outer shell. Helium, although it has 2 electrons on its last shell, it is not placed in group 2 because it has a filled outer shell. The first shell can hold a maximum of 2 electrons. Helium is not in group 2 because it has a filled outer shell, and the elements with filled outer shell are placed in group 8 of the periodic table. So in group 8, we have helium, we have neon, and we have argon. That's clear? Are we clear?
Yes, miss.
Yes, miss.
All right, so we need to remember all the elements in the periodic table, as I said. So we need to know elements in group 2, calcium, magnesium, calcium, elements in group 3, boron, aluminum, elements in group 4, carbon, silicon, elements in group 5, nitrogen, phosphorus, elements in group 6, oxygen, sulfur, elements in group 7, what's that saying? Elements in group 7, fluorine, chlorine, bromine, iodine. We need to remember those 4. So it's not just the two in the 20 elements. We need to remember the additional 2, which is bromine and iodine. Elements in group 8, helium, neon, argon. Is this clear? Hello?
Yes.
So you need to memorize those. No, all the elements that are in group 1 to 3, those are called metals. All the elements in group 1 to 3, those are classified as metals. So that means that metals, remember, what do we use to determine the group number?
The amount of last electron.
The number of electrons on their last shell. So therefore, metals have 1 to 3 electrons on their last shell. Elements in group 4 to 8 are called non-metals. Therefore, what does that mean? What about these? How many electrons do they have on their last shell or their valence shell?
4 to 7.
4 to 8. Those in group 8 are also non-metals. So the gases, the noble gases, are non-metals. We don't talk about it a lot, but they are non-metals. Don't worry, my students have the same misconception. So all the elements with 1, 2 electron, 3 electrons on their outer shell, we classify them as
Metal.
We classify them as metal. Elements which have 4, 5, 6, 7, 8 electrons on their outer shell, we classify them as based on Roman numeral. It's 1 to 3. And those in group 4, we number it 1 IV, and then it's V, I. This is clear?
Yes, miss.
All right, so our aim is to do formula writing. You may be saying, why is this lady going all the way down here? Why she do all of this? I'm doing all of this because if you don't understand this, you won't understand why we need to write formulas anyway. The reason why we write formulas is because of the notes in pink. Elements in group 8 of the periodic table are stable, and they are stable because they have filled outer shell. All other elements are unstable and will form bonds in order to complete their outer shell. So the reason we have formula anyway is because elements are to become stable, they are going to react to 1, 2, 3, 4, 5, 6, 7 they are unstable, and to become stable, they need to have a filled outer shell. They need to have a what?
Filled
outer shell.
In order for them to have a filled outer shell, they will need to form bonds. This is the fundamental basis on how formulas are created. You know? Yep, a 2 mark label, you know? 2 mark label. Enjoy. Yes. Ready? Ready? So every other element, in order to become stable, they are going to form bonds. All right. So all elements in a particular, all right. So all elements in a particular group will undergo the same reaction. Remember, what we're trying to do is to have filled outer shell, right? What we are trying to do is have filled outer shell. Now, all the elements with the same valence electron, same number of valence electron, aka all members of the same group, they are all going to react the same way. And that is why if you study those in group 1, I know it's lithium, sodium, potassium, when you react, they are always going to do the same thing, right? When you write formula for a reaction between any metal in group 1 with an acid, the reaction will be the same. When we react or we write formula for any element in group 1 and any element in group 6, it is going to be the same thing. So what we need to understand is the number of electron on the last shell. Well, the electron determines the chemical property. That's the note that you need to make. The electrons determine the chemical property. And all elements with the same number of electrons on their last shell will react the same way. Is this clear?
Yes, miss. Yes, miss.
Good. So elements in a particular group will react the same way, since it's their valence electron which will predict how they react. Elements will react by losing.
Miss,
Yes.
can you repeat what you said a while ago?
Which part?
Where the electron determine the chemical. That's right.
Property. And all elements is there after the point in pink. All elements in a particular group. Hold on. All elements in a particular group will react the same way, since it's their valence electron that will predict what the students are mixing up right there. So we're going to fix that.
Miss, I don't know why, but the audio keep going in and out.
I'm breaking up for everybody else.
Yes, miss.
Yes,
Sure.
yes. Yes.
I'll fix that. I don't know. The Wi-Fi is not working. I'm on my data. Yep. Hearing me? Hello?
Yes, miss.
Yes, miss.
Okay, all elements in a particular group will react the same way, since it's their valence electron which predicts how they react. Elements react by losing, gaining, and sharing electrons, and they form bonds. So elements, in order to become stable, they react to become stable, and when they react, they are losing or gaining or sharing electrons. And when they lose, gain, or share electron, these form bonds. Clear?
Yes, miss.
No, they are different types of bonds. We have 3 types of bonds. We have ionic bonding, which involves the loss and gain of electrons. We have covalent bond, which involve elements or atoms sharing electrons in order to become stable and they form covalent bond. In metallic bond, this has to do with only the loss of electron. Metals will lose electrons. Clear?
Yes, miss.
Yes, miss.
Yes, miss.
All right, I'm gonna do something quick and fast and quick because I have an hour to go. I have an next class at 6, so I need to go prepare for my 6 o'clock class. All right. We just want to make sure that we wrap up everything and we're going to bonding. I like to wrap up to make sure that we understand what's happening. So we're going to wrap up what we have learned just now, and we are going to go ahead and answer some questions, making sure we're all on the same page. So here we have a period table, right? Here we have a periodic table and we're going to use, all right. So the first thing we're going to do is number a periodic table. We number the groups first. So this is group 1, 2, 3, 4, 5, 6, 7, 8. Clear?
Yes, miss.
Period 1, 2, 3, 4. All right, so go answer B. Using only the elements indicated in the table above to answer the question which follows. Each element may be used once, more than once, or not at all. Write the symbol of halogens. Which group of the periodic table did we say halogens are formed in?
Group 7.
Group 7.
So what are the atoms that we're seeing there from this table only that belongs to group 7?
Chlorine
Bromine.
and bromine.
Write the symbol for the atom which has 4 valent electrons. Element with 4 valent electrons are 4 electrons on their last shell. Which group do we have those in?
Group 4.
Group 4.
So we're going to write what?
Carbon and
silicon.
Good. Write the symbol for the alkaline earth metals. Alkaline earth metals belong to which group of the periodic?
Group 2.
Group 1. Group 2.
Group 2.
Group
Alkaline
2.
metals. Alkaline earth metals belong to group 2. So where are they?
Beryllium and calcium.
And it says give the symbol of 3 metals. Metals belong to which group of the
Group 1 and
table?
group 3.
Where are the metals that we have here?
We have beryllium,
Beryllium, carbon.
calcium.
Calcium, not carbon. Carbon is C. Calcium is Ca. And aluminum. Then it says give the symbol of 3 non-metals. What would be the symbol of 3 non-metals?
It would be phosphorus, chlorine, bromine.
Or neon, carbon, silicon. All of these from group 4 to 8 are non-metals. So any of those 6, any 3 of those 6 would give us our answers for F. So on 2 elements in period 2. Which 2 elements are in period 2?
Beryllium and carbon.
Beryllium, carbon. So this is the period 2. Why are we placing them in period 2?
They have 3 shells.
Period 2?
Miss, because
They have 2 shells.
because they have 2 shells.
So they have 2 shells, so we're putting them in period 2. The number of shell determines the period number. Clear?
Yes, miss.
All right, so give the symbol of a stable element. What's the symbol of an element that's stable?
NE.
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 The only stable elements we're saying belong to this group of the periodic table. It is Ne. Are we clear?
Yes,
Yes, yes, miss.
Yes, miss.
All right. So we're saying every other element in group 1 to 7 need to become stable. And in order to become stable, they can lose, gain. They can lose, gain, or what?
Share.
What are they losing, gaining, or sharing?
Electrons.
Electrons.
All right, good. So moving on. Bam, 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 bam. Okay. Stop sharing. All right, so today we're going to focus on what happens when elements lose or gain electrons to become stable. So in this scenario, we are going to figure out what elements will do to become stable. Clear? So elements in group 1 so when elements lose or gain electrons to become stable, they form ions, right? When elements lose or gain electrons to become stable, they form ions. Ions are charged atoms formed when elements, they are charged atoms formed when elements lose or gain electrons to become stable. Why not change color? Note well, electrons are negatively charged so electrons are negatively charged when electrons are lost the atom becomes positive. So what is happening is, since electrons are negatively charged, if you lose them, you're going to become positive. Clear?
Yes, miss.
Now, if you should gain electron, what's going to happen to you?
Negative.
Become positive.
It will become negative.
Let's go again. Electrons are negatively charged. So if we lose electrons, we are becoming more negative.
Positive.
Positiveness.
Oh yeah, lose. We're becoming more positive. Sorry, I
Yes,
was
yes,
trying to
yes.
answer the question I asked. So when we gain electrons, we are gaining negative charge. And when we gain negative charge, we are becoming more
Negative.
Positive. Positive.
Yeah. When we lose, Miss, we're becoming more positive.
Lose electron, we become positive. And when we gain electron, we or it
Become more
become
negative.
gain electrons, it becomes negative. Clear?
Yes, Miss.
Now listen. We said that all elements in the same group will react the same way. That is, they will lose or gain the same number of electrons. Clear?
Yes, Miss.
All right, so we define ions as charged particles formed when elements gain or lose electron. And we're saying that when they lose electron, they are becoming positive. And when they gain electron, they are becoming negative. That means we can have two types of ions. Are we following?
Yes, miss. Yes, miss.
Yes, miss.
So we can have a cation
Or
and
an
an anion.
anion.
The cations are positively charged ions formed when metals lose electrons in order to become stable. So which group of the periodic table are we going to find metals in?
Group 1 to 3. Group 1 to 3.
The elements in group 1 to 3 So elements in group 1 to 3 have to lose their electron. So elements in group 1, how many electrons do they have?
1 electron.
So they have 1 electrons on their outer shell. How many electrons will they lose?
1.
So if they lose 1 electron to become stable, their charge is 1 plus. This results in a +1 charge.
Miss, excuse me, could you go again with that? You said +1 charge. So if the element in group 2, if they lose 2 electrons,
Yes.
is it +2 just the same as you said, +1?
+2, yes, sir. +2, because once they lose 2, their charge is, so your charge is positive the number of electrons lost. So those who lose 1 electron will be +1. those who lose 2 electrons will be positive 2. And those metals with 3 valence electron, they are going to have a charge of +3. Are we clear?
Understood, miss. Understood.
So the number of electrons on your last shell, right, will determine the number of electrons you lose or determine the number of electrons you gain. The number of electrons we lose, right, number of electrons lost is equal to a positive that number of electrons lost. The elements in group 1, in order to become stable, they lose 1 electron, so their charge is +1. Those in group 2, how many electrons will they lose?
2 electrons.
Magnesium and calcium, in order to become stable, those are group 2 elements. They need to do what?
Lose 2 electrons.
And when they lose 2 electrons, their charge is +2. Clear? Or 2 plus. Those in group 3, their charge is going to be +3 or 3 plus. Clear?
Yes, miss.
I will give you a table shortly that you can write off. None. So we're going to define anions. Anions are negatively charged ions formed when non-metal. Is all non-metal going to form ion?
No, miss.
Those in group 8, those will form ions?
No, miss. No, miss.
No, miss, because they're already stable.
Good. So elements in group 4, group 5, group 4 will not form ions either. Elements in group 4 to 7.
This would group 8 elements bond covalently.
They wouldn't bond at all. Group 8, remember, bonds are formed when you want to become stable. And if elements in group 8 are already stable, so they do not form bonds, they are unreactive. Clear?
Yes, miss. Yes, miss.
Yes, miss.
So anions are negatively charged ions formed when non-metal will gain electron to become stable. These non-metal will gain electrons to have 8 electrons on their outer shell. All right, so elements in group 8, how many electrons do they have? Group 8 have how many electrons? 8 electrons. The elements, so every other element, they want to have 8 electrons in order to become stable, right? So elements in group 5 have 5 electrons and they will want to gain how much more to have 8?
3.
Here is electron. Those in group 6, what will they do?
Need to become stable.
Elements in group 7, how much will they gain?
1 means electrons.
What happened to you now? Sleep for me. As I don't sleep it, you know. Elements in group 7 will gain how many electrons?
1, Miss.
One electron.
So that's the number of electrons that they're going to lose, right? And elements, so the number of electrons they gain, their charge is going to be negative. The trans are they gaining? Elements in group 6 are gaining 2, so their charge is -2. Elements in group 7 are gaining 1 electron, so their charge is -1. Is this clear?
Yes, Miss.
Yes, Miss.
All right, so here we go. We are going to take down a table. And then we move into formula writing. Are you seeing my screen?
No,
Yes.
Miss.
No, Miss.
No, Miss.
Okay, so remember for the atomic notation, right? I've shown you that briefly. The charge goes at the top right-hand corner. C is the charge, and the charge goes where? At the top right-hand corner. Where does the charge go?
Top right hand corner.
At the top right-hand corner.
Here we have a table that you're going to take down for me. Table show how each element in the periodic table form ion in order to become stable. Elements in group 1, they lose. So there's a new term here that we have not discussed. And the term that is there is I'm finished. So valency. Valency now is the number of electron actually at lost or gain. So that do have a number, right? So let's go. Elements in group 1 lose 1 electron, and so their charge is +1. They will have a valency of 1 because they lost 1 electron. Example, H+ ion, which is hydrogen ion, Li+, which is the lithium ion, Na+, which is the sodium ion, K+, which is the potassium ion. We have group 2. Elements in group 2 are going to lose 2 electrons in order to become stable. So their charge is going to be +2, and because they lost 2 electrons, their valency is 2. So the valency is the number without the plus sign. Are we seeing that?
Yes,
An
Miss.
example are magnesium 2+, the magnesium 2+ ion, calcium ion, which is Ca2+. Remember, the charge goes where?
Top right hand corner.
Top right-hand corner.
Goes where? Top right-hand corner. Ready? Elements in group 3, they lose 3 electrons, so their charge is +3 or +3 or 3+. So the valency is 3. Example is aluminum. Boron and beryllium are not in the table because they show diagonal relationship. So we don't necessarily put them in this table. Those in group 4 don't know if they need to lose 4 or gain 4. So as a result, they do nothing. They don't form ion. Elements in group 8 needs 8 electrons on their, group 5 needs 8 electrons on their outer shell, so they gain 3. Their charge is -3 or 3-. So it's N3- P3-. Elements in group 8, group 6, I keep saying 8. Elements in group 6 need 8 electrons on their outer shell, so they're going to gain 2, so they can have 8. 6 + 2 is 8. So they gain 2 electrons, have a charge of -2. Example is O2-, S2-. Elements in group 7
Excuse
gain
me?
1 electron. Pardon?
I was asking if you could repeat what you said about group 4, because I didn't catch that one.
They don't gain nor lose electrons. They don't form ions. You add up each question. Then I'm going to take a whole day. Ready? Elements in group 7 have 7, need 1 more to get 8, so they'll gain 1 electron. Their charge is -1, and so they have 1 as the valency. An example is F negative, Cl negative, Br negative, I negative. So we have the fluoride ion, the chloride ion, the bromide ion, and the iodide ion. So when non-metals form ions, their ending change. So nitrogen becomes nitride ion. Phosphorus becomes the phosphide ion. Oxygen becomes the oxide ion. Sulfur becomes the sulfide ion. Clear?
Miss,
Yes,
clear,
ma'am.
but a little, I'm a little confused. Why the ide? Why is it
That's
so?
what they're called. Once the non-metal by themselves change the end, change to an ion, they become ide. No,
Okay.
those who do it already and are in grade 11, you will know that once the non-metal have oxygen, they now become nitrate, nitrite. If it's sulfide and you have oxygen on it, you have sulfate, sulfite. That's just the nomenclature. Nomenclature is how we name stuff. That's just how the chemists are naming them. When they form the ion, they are no longer atoms. So that is why when I spoke about H+, I spoke about hydrogen ion. When I talk about lithium plus, Li+, I spoke about the lithium ion. We don't talk about oxygen ion. We talk about the oxide ion. We talk about the phosphide ion, the fluoride ion, the chloride ion, the bromide ion, and the iodide ion. That's just how we name it. That's just the rule. Ready?
Yes, ma'am.
Yes.
I'll move on from the table. No, yes, yes, no.
Yes, miss.
Yes, miss.
It was Albany. I think you might go that object. Ready? Ready?
Yes, miss.
Okay.
So we're going to, so elements that form ions, they form ionic bonding. So now we are going to write the formula for ionic bonding. We are going to write formula for ionic compound. The first thing we are going to do is we are going to, and I follow my rules to the T. I teach principle and I am referring back to my principle always, 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 always. So when I talk, I only talk principles. I don't have any time to talk anything else. We study principles and you apply them to example. A lot of students study example and don't know principle. We don't do that, we do principle. So when you write the formula for ionic compound, the first step we are going to do is to write the symbol of the ions in the compound. Clear? That's step one. Everybody has to write step number one. We are writing the symbol for the ions in the compound. Once we write the symbol for the ions in the compound, we will rewrite the symbol without the plus or minus sign. That is writing the valency. Therefore, the valency. Therefore, write the valency. All right. Then number 3, we are going to swap the valency. We are going to swap the valency. When we swap the valency, rewrite you rewrite the formula with the swap. And if your teacher don't teach you that, that's fine. This is how I think it's easy for my students to remember it. So this is how I do. We write the formula with the swapped valency as a subscript. So number 1, we are writing the symbol of the ions in the compound. Ionic compounds is what we're writing the formula for. So they have a metal and a non-metal ion. We will write those formula. We are going to rewrite that without the plus or the minus sign. Then we are going to swap the valency. When we swap the valency of the non-metal will become the subscript of the metal, and the valency of the metal will become the subscript of the non-metal. Okay, what do I mean? Are we finished writing this?
Yes,
Yes,
miss. Yes, miss.
All right, remember, I said all the elements in a particular group will react the same way. So our group 1 elements will react the same way with group 3. All right, let's go. Oh, I missed something, but we will clarify that shortly. Note well, if the valencies are the same, if the valencies are the same, we only use one of each atom. I will clarify that shortly. So we're gonna write the formula for sodium chloride. It says that we are to write the symbol of the ion. So in our table we wrote earlier, what is the symbol for the sodium ion?
Na
plus.
Na
Na plus, the ion.
Cl.
The plus is critical. The ion has a +1 charge. Sodium is in group 1, so to become stable, it lost an electron, so its charge is +1. Are we clear?
Yes, miss. Yes, miss.
Chlorine is in group 7, so the formula for the chloride is
Minus.
good. That's step number 1. We have done step number 1. Step number 2 says I am to do what? Rewrite the formula without the plus or the minus sign. So that means it's if this is +1 and chloride is -1, that means without the plus sign, sodium is 1, chlorine is 1. Clear?
Yes, yes.
Yes, miss.
Yes, miss.
So then it says, I am going to swap. This is where students make the mistake, and we're not going to make any mistakes. So let's go. We are going to swap. When we swap, I am taking the number right here and I'm putting it at the bottom of the non-metal. So sodium 1 comes here and the 1 for the chlorine comes right here. Clear?
Yes,
Yes,
miss.
So it would be sodium 1, we don't write 1, Cl1. Clear? So sodium chloride is NaCl. Clear?
Yes, miss.
Miss, could you go back over that, please?
It's interesting.
We write the formula of the ions, right? We write the formula of the ions, right? Sodium is +1, but I'm writing it now without the plus or the minus sign. So it's sodium 1. Chloride 1. So I write it back without the plus or the minus. Then I will swap. When I swap, this number at the top of sodium goes to the bottom of chlorine.
Mhm.
Number goes here. Clear?
Yes,
So
miss.
this means that it is sodium 1, chlorine 1. Clear?
Yes, yes, miss.
Yes, miss.
No, we do not write 1. When X is 1, we just say X. Same thing for the number of entity. Remember when we look on the atomic notation, we said D is the number of entity. So what this is saying is it is 1 sodium, 1 chlorine, but we don't write 1 in algebra. So it's Na1, chlorine 1, but we don't write that, so it becomes NaCl. Is that clear?
Yes, miss.
Mhm. Understood, miss.
Remember we say all elements in the same group will react the same way. So here we have a group 1 reacting with a group 7. Let me get another group 1 and another group 7. Give me a group 1 other than sodium and hydrogen, please.
Lithium, miss.
Good. Give me another group 7.
Bromine.
Bromide ion. So it's lithium bromide. Okay, let's go. Let me get some specific people to talk to me now. Hamilton. Calicia Hamilton, let's go. No, don't want to talk to me. Davin. Don't want to talk to me. Jade. I don't want to talk. But I don't want to talk to me. If you want to talk, raise your hand. Lashantia likes my company. Raise your hand. You want to talk to me, Lashantia? Let's go.
Okay.
Yeah.
Hi.
Class. Let's
Exactly.
go.
Exactly. All right, Miss Lithium, Li +1. Bromide, Br -1.
Good. All right. What's the next step? I see a Samsung Galaxy raise their hand. What's the next? Or his hand? Samsung SMA, whatever. What you saying? Unmute and talk to us. What's the next step?
All
What's
right,
the
miss.
next step?
So you will rewrite the formula by writing L1 and B1 BR1.
Then this is the next tricky part. Get your arrow. What do? I swap, and the number up here goes as the subscript down there. The number up here comes down there. So it's lithium 1, Br1. So they have the same valency. Remember I said note, well, if they have the same valency, it's 1 of each. So it would be Li Br. Clear?
Yes, miss.
Notice sodium chloride have one sodium, one chlorine. Both of them are in group 1. When group 1 reacts with 7, group 7, it's one of each. So LiBr. That's the formula of lithium bromide. That's clear?
Yes, miss.
Yes.
Excuse me, Miss.
Yes, ma'am.
Miss, if you were to do it with, say, a group 2, would it
Okay, let's go. Give me a group 2. Give me a group
magnesium
2. Yes.
and let's say chlorine?
Chloride. Let's go. What's the symbol of the magnesium ion?
Two.
Plus.
Oh, plus 2.
What's the charge on the chloride ion?
-1. Cl-.
Good. What's the next step? After I do that, what's the next step?
So write this swap.
So it's Mg2Cl1. Then what's the next thing that I'm going to do? I'm going to swap. 2 goes there, 1 goes here. So this is Mg1Cl2. So magnesium, we don't write the 1, so it's magnesium, and we have
Cl2.
Cl2. That's clear. The 2 goes at the bottom right hand corner. You just start, girl. Too dramatic. Ready? Magnesium chloride. That's clear?
Yes, miss.
Yes, miss.
Calcium fluoride. Let's go. Let's go. Talk to me now. Calcium fluoride. Let's go.
Miss calcium plus.
Fluoride.
Is F-.
Let's go.
Rewrite the symbol without this the valency, and then you swap the valency.
So it's Ca1,
F2.
F2, and we don't write 1, so the formula is CaF2. So notice, when group 2 reacts with fluor with any group 7, we always need 2 at the group 7. So what we're doing is canceling the charge, right? So calcium is 2 plus. If fluorine is, so calcium is 2 plus. We want to balance out the charge. We get 2F because we would need, what we need? 2 times the negative gives us, we'll cancel out the 2 positive, done.
Excuse me, miss.
Yes, ma'am.
So basically you're saying whenever you react a group 2 element with a group 7 element, the group 7 element will become a diatomic.
No, not diatomic, but it has 2 entities. Diatomic is when it's by itself. So
Okay.
remember, they are diatomic naturally, but in compound, we use 2 of them to balance out the 2 plus charge.
Okay, miss.
Better right now.
Yes.
Excuse. Why is your baby cold though?
No better calm down. Because I look fat.
Aluminum oxide, let's go quick and fast.
Al.
Al
Aluminum
plus
is
3. O2 minus.
Good.
Miss, would it be
O2, and then we're going to swap. Let's go. What would be the charge? So when we swap, 3 goes at the bottom here. So it's Al2O3. Clear?
Yes, miss.
Ready. So we're going to look on lithium oxide. So lithium oxide is L is what?
Li
Plus one is
plus 1.
And we have,
Is O2 minus.
so we will rewrite it as Li 1 O2, and then we are going to swap. So this becomes 1 and this becomes 2. So it is Li2O1. So it's Li2O. Clear?
Yes, miss.
Any questions?
No, miss.
So we have aluminum nitride. Aluminum nitride now. What's the charge on the aluminum ion?
plus 3.
Plus 3.
Plus 3.
What's the charge on the nitride ion?
3 minus. And 3
So
minus.
how many nitrogen I need to cancel out? 3 minus. How many aluminum would I need to cancel 3 minus?
3, miss.
You may have 3 plus. And this
1.
is 3 minus. Don't they just cancel out? So I need 1 of each. So let's go. Both of them now have the same valency. So there's 2 ways to look at it. We have Al3 and 3. When we swap, both have the same valency. So it's Al3 and 3. And we said when the valencies are the same, we use 1 of each. Now, how we get that? 3 is in both compounds, so we're going to divide both of them by 3. So we end up with Al1N1. Or you can say Al3N3, both have the same valency, so they cancel out, so it's Aln. Clear? So you can divide like I did right here, or you can say Al3N3, both have the same valency, so we cancel them out. However you want to remember that one. Hello? I'll divide.
Yes, miss.
Yes, miss.
All right, we'll do another one. We're going to do calcium sulfide. So calcium sulfide, what's the charge on the calcium ion?
2 plus.
Plus. Plus.
Sulfide, 2
2
minus. So we have Ca2S2. We're going to swap. The 2 goes to the bottom here. Both of them have 2, so we're going to divide by 2. So it's 1, 1. So many calcium do I have? 1. How many sulfur do I have?
1.
So the formula for calcium sulfide is CaS.
Miss, what if you were to say like a group 2 element and a group 4 element, like
Remember,
beryllium?
group 4 don't form ionic compound.
Okay, miss.
Remember, we must have a metal and a non-metal. So beryllium and sodium will not react
Okay, miss.
because they're not the same.
Miss, I didn't say sodium, miss.
Beryllium and calcium will not react. Both of them are metals.
I didn't say calcium with them, Miss. I said carbon.
Oh, not going to react.
Okay, Miss.
Group 4 don't form ions. We're talking about ionic compounds. So we have a metal and a non-metal. All right, so do we understand when the charges are the same? Let's work one more, and then I'll give you some to do. I have an extra class. So, I'm telling about my business now. Yeah, I have to tell them my business. Mr. Share. What? So I never tell I have to send today. Look from when we're gonna do the recording. All right, ready. So my name is Natalia White. I am the founder of the Online Science Academy. I have extra class in chemistry and physics and biology. I have the author of the CSEP Bio book. She's also the co-founder of the academy. She teaches bio. Bio class is on a Monday. Grade 11 chemistry class is on a Sunday, 6 to 8. And we have grade 10 chemistry class Tuesday, 6:30 to 8:30. On a Wednesday, we have physics, 6:30 to 8:30. So if you're interested in the science and you found this class interesting, interactive, you may WhatsApp me the class. The cost of the class is if you do one subject, it's $10,000, and if you do two subjects, you get a discount. So once you do more than one subject, your monthly bill is $8,000. So if you do more than one subject, $10,000 monthly. My name is Natalia White. You may message me on WhatsApp. This is only my WhatsApp number. 3537322. This is the WhatsApp number to sign up for the classes. Are we learning here? Yeah. We learn?
Yes, Miss.
Yes, Miss.
If you want to learn further, I teach the chemistry and I teach the physics. So if you want to learn further with me, you may join my class. I also have a grade level class on Saturday. And from 3 to 6, it's going to be from 3 to 6. So that one, the cost has to be 10K. So the cost for the Saturday class, and that class resumes in February, the first Saturday in February, and we're going to start mole concept. If you're really, really struggling, I have a class where I'm kind of going through everything on a Sunday, so you may want to join that. But if you want to do mole concept, you can join me on Saturday, the first Saturday in February. But for physics, we are moving on to Newton's law with one topic per week, and we are intending to finish the entire syllabus by May, near to the time for the exam. So if you want to learn chemistry with me, this is how, and physics and biology. Yeah, I'm gonna do electricity. I think I'm gonna do it in March, April. All right, so if you're interested in the class, send me a message and we will work together. But I'm committing on a Sunday to teach you what you need to do formula formula writing, balancing equations. So today we are able to write formula, maybe ionic equation. All right, ready? Here we are. Somebody's saying they're not hearing me. Nobody's hearing me?
Yes, I'm here.
So we're going to do calcium oxide. Calcium, Ca, 2 plus, oxide, 2 minus. We are going to write it back without the plus or the minus sign. So we're going to divide both by 2 and we'll get CaO. Clear?
Yes,
So it will
yes.
be one of each. Now it's your turn. We are going to write the formula for aluminum chloride. Lithium sulfide. So we're only doing the first 20 elements. We're not doing the polyatomic ions just yet. Calcium nitride. Boron Not boron. Can't do beryllium either. Magnesium, iodide, potassium, what is no? Potassium, or somebody said bromide. Oxide, no. Oxide, magnesium. What is no? Group 1, lithium. Nitride, phosphide. Yeah, one, me just can't remember the charging. I know it's supposed to be in my bag. When I said I'm ready. What is this? It's probably on charge. So let me see.
Where you can get them book here to buy
People give me them from like journal. These are nice girls, so people give you nice things.
export here.
All right, so these are yours to do.
Yes, I'm finished.
All right, I can send it in the WhatsApp group if you're in there.
Yes, I'm not in the WhatsApp group.
Yeah, in the WhatsApp group.
No, miss. It was sent to me by a friend, the link.
But I never send her the
You have good friend, girl.
she have good friend.
Me. That's like in your class, but me no want to make it bad for you.
Let me find the link for the WhatsApp group.
The free class link. Which one?
1 minute.
Free? WhatsApp group?
Can I relax?
Wait, so me can't send it to you.
No. Resend. 1 minute. Looking for the form. They can register. Mm,
21.
No. So I shared the WhatsApp group details, so we will just use that to, somebody can share the link in the chat here, please. So anybody who is on the phone, you can just go to in the WhatsApp group. Can you just copy the link and put the link in the chat right here? This is some information I need you to take down and memorize them for next week's class. If you don't have these memorized for next week's class, you're going to have some issues in doing them. So it's not just the first 20 elements that form ions. There are some other elements that form ions, and we have a whole list of them that we need to study. Here is the list. So I'm gonna ask you to take a picture of this and study these for me for next week's class. So you must study these for me next week's class. Somebody
So
share
Miss,
the link
this
for me.
class is every Sunday.
For the next 3 weeks we have left, so we meet for 4 weeks. This is the first week, so it's until February we meet here. All right, what's the formula for the first one? What's the first one that we were to do?
Aluminum.
Which one?
Miss aluminum chloride.
Everybody have that?
Yes, miss.
Next one.
Lithium sulfide. Li2S.
Li2S. Number 3.
Calcium nitride.
Calcium nitride. Ca3N2.
Ca3N2. Next one.
Magnesium.
Potassium.
No, potassium bromide. KBr.
Next one.
Miss, we skipped one. It was
Magnesium.
magnesium iodide.
I don't know. I'm doing what you wanna say. Next one.
Magnesium oxide.
MgO.
Lithium
And
nitride.
lithium.
Li3N2.
We get N2. Lithium is 1, nitrogen is 3. So the 1 from the lithium goes here and the 3 from the nitrogen comes here.
Miss,
So
was
it's
it
Li3N.
lithium oxide, miss?
Oh, I don't know. When me hear, I don't know. I've lost it. So it's lithium oxide. So it's Li2O. All right. Any questions?
Oh, miss.
All right, so I just want to take some feedback from today's class. I said I'm ending at 5:40, so I am at wrap-up time. How was the session? If you don't mind coming on video, sharing. Share my video. What one must tell me? So anybody wants to come on video telling me how was the session?
Miss, I don't want to come on video, but I still want to speak.
All right, hold on. Let's get it.
So it was pretty good. It was an easy way of explaining the concept instead of going a very long, confusing route. It was pretty simple. And I like the way how you did it, and you're quite interactive with your class.
Thank you. What's your name?
My name is Iman Jenkinson.
Okay, thank you. Anyone else want to share? Let me know your name as well. Why that never look like the ear record? Anybody else want to share? Yeah,
All
but
right.
in other class.
Good evening, my name is.
Go ahead.
Good evening, my name is Naxia. I've found this class very interesting. And you refreshed my mind on some things that I didn't remember from last year.
True, true.
Thank you. Anybody else?
All right, Miss, for me,
Anyone else?
Miss, it was very interactive. You made it so simple,
Okay.
so we could understand, and I'm grateful for your explanation.
Miss Anna also found the ionic
Anybody else?
method interesting.
Miss, also, the class wasn't mediocre, seeing as it was,
Thank you.
Miss, seeing as it was a free class and you could have just like, you know, do anything, Miss, but it wasn't mediocre. You put in effort into teaching properly, Miss, even though it's free.
Yes, ma'am.
1 + 1 0.
1 + 2. All right, no, 1.5. Sorry. All right, thank you so much for coming. Thanks for sharing. I'm thinking about starting a YouTube. Would you guys watch?
Yes,
Yes, Miss, thank you for your time.
Okay, you're welcome. Now you can find me on IG. I have not posted any videos on IG recently, but you can find my IG. I'm going to be start sharing more chemistry content. It's Online Science Academy. So on IG, Online Science Academy, I have some videos. I used to go live on Instagram a lot. I haven't gone live there for a long time, years. So I intend to restart that. So you can follow my page. And when I upload my first YouTube video, I'll share it in the WhatsApp group. So thanks for watching, thanks for participating, thanks for listening, thanks for the testimonial. I will see you next week Sunday, at 4. So take a friend with you. We're gonna start writing equations next week, Sunday. So tag along. Bye.